Hi, this is Mrs. Young, and this lesson is on spheres, volume and surface area of spheres. So our bell ringer today is going to be a review of volume on some of our other shapes. So the first one says find the volume of a cone with a base circumference of 12 pi and a height 6 more than half the radius. So you're going to use that base circumference of 12 pi to figure out what the radius is. Once you figure out the radius, then you know the height is 6 more than half of that, and then find the volume of that cone. And then you can see in problems 2 and 3, these are two composite figures. So in number 2, you're going to find the volume of the cone on the left and then the pyramid on the right, and then add those two volumes together. In number 3, you're going to find the volume of this half cylinder on the right side, and then the prism at the bottom, and then add those two volumes together. So go ahead and pause the video, and you can do this in your spiral or wherever you have space or paper. Practice finding the volume of these three shapes. So pause the video. So here you can see in number 1, I got a volume of 339.3 centimeters squared. My radius was 6 and my height was 9. Then in number 2, this one, we have a volume of 21.4 feet cubed. Again, the cone on the left was 3 pi, the pyramid on the right was 12. Adding those together, we get 21.4 feet cubed. And then finally in number 3, my half cylinder, if this whole distance was 4, half of that is 2. That's my radius of my half cylinder. So half of pi r squared h, that's 30.6 pi. And then the prism was easy, just 6 times 4 times 15.3. I got 367.2. Add those two together and get a total volume of 463.3 feet cubed. So go ahead and check your answers over and pause it if you need to double check the answers you got and compare them with mine. Okay, so on to spheres. Maybe what I'll do first is help you draw a sphere. I know that we've taken time drawing shapes before. When I draw a sphere, you can try this with me. Again, I'm not really the best at circles, but draw a giant circle for your sphere. Not bad. Okay. And then to make it more three-dimensional, I kind of draw like the equator, like a line around the middle. But in the back, I make it dashed. That's not bad. Well, that's not great. I don't like it. So again, drawing this kind of like the equator around the middle. Maybe that's a little better. And then again, just to make it even more three-dimensional, I can draw another one coming down through the middle, right? Again, many of you are better at drawing than I am, but there's my picture of a three-dimensional sphere. You will have a point in the center. That's the center of your sphere. And then if I go from that point in the center out to the edge, that's the radius of my sphere. So a couple things about a sphere. Our definition: a sphere is the locus of points in space that are a fixed distance from a given point, called the center of a sphere. A radius of a sphere connects the center to any point on the sphere. A hemisphere is half of a sphere. And a great circle divides a sphere into two hemispheres. So again, the great circle is kind of like this circle going through the middle. It's got to hit the center point. It's the biggest circle when you slice a sphere directly in half. And again, it can be going any direction, right? I could have a great circle, you know, going through this way, just as long as it goes through the center. So you can, you know, imagine taking a perfect circle and slicing it right down through the middle. That creates, if you cut it through the middle, that creates a hemisphere. And that circular region is your great circle. We do have a couple of formulas for a sphere. So I'm going to go ahead and start with my first formula, volume of a sphere. The volume of a sphere is 4/3 pi r cubed. Make sure, again, in addition to drawing your sphere and writing down your definition, make sure you include this formula. The volume of a sphere is 4/3 times pi times the radius cubed. I guess cubed makes sense to the third power. We're in the three-dimensional space. And now once you've got that copied down, we're going to do a few practice problems with spheres. So my first example here, it says find the diameter of a sphere with a volume of 36,000 pi. So this one I'm kind of working backwards. So we're going to start with our formula. Volume equals 4/3 pi r cubed. And I can plug 36 pi in for the volume. Sorry, 36,000 pi is equal to 4/3 pi r cubed. And I'm trying to figure out first what the radius is, and then I can double that to get my diameter. Well, obviously, if I'm trying to solve this for r, the first thing I would do is divide both sides by pi, and the pi's cancel out. And then again, I'm trying to solve this for r, so I want to get rid of the 4/3. So I'm going to multiply both sides by 3/4. So multiply both sides by 3/4, multiply by the reciprocal, right? 3/4 times 36,000. Well, 36,000 divided by 4 is 9,000, and then 9,000 times 3 is 27,000. Or if you'd rather, you could use your calculator right there, right, to help you figure out what 3/4 of 36,000 is. And then finally here, I'm trying to figure out what the radius is. So I need to take the cube root of both sides so that the cubed and cube roots cancel each other out. So I can have the radius. What is the cube root of 27,000? Now, a lot of you probably even know what that is, but I just wanted to explain to you that you could even do this calculation on your calculator if you wanted to. If you have a TI-30, there's a button that's like a little up arrow button somewhere on the left side there next to x squared. But above that little arrow button on the calculator, it says x root. So you can take the x root of something, something that's not a square root, maybe a third root, a fourth root, a fifth root. It's kind of a nice button on the calculator, nice feature. If I want to take the cube root of something, the third root of something, so in my calculator, I would first push the button 3, then I would push the second button, and then the up arrow, because again, I want to take the x root of something, and then I would take the x root of 27,000. So if you type all of that into your calculator, the cube root of 27,000, hit equal or enter, you would get 30. Again, that would make sense to you, because I'm pretty sure you guys know that the cube root of 27 is 3, right? So the cube root of 27,000 is 30. Now, if my radius is 30, the question is, if I go back to the problem, they said find the diameter. So my diameter must be 60. Again, that's 60 centimeters. So I just wanted to show you here when we're working backwards how you can take the cube root of something on your calculator. The next problem, we'll go past that one. There we go. Find the volume of the hemisphere in terms of pi. So again, we know that the volume of a sphere is 4/3 pi r cubed. But if we have a hemisphere, remember that's half a sphere, so you have half of 4/3 pi r cubed. You can just use the equation just like that. That's completely fine. Some of you might realize, though, that half of 4/3, right? If I take half of 4/3, I get 4/6, which is 2/3. That makes sense because half of 4/3 is 2/3. So sometimes students will remember, oh yeah, it's a hemisphere, so it's really 2/3 pi r cubed. Or again, like I said, you could just say half of 4/3 pi r cubed. However you want to remember that for a hemisphere. So in this problem, I would have 2/3 times pi times my radius, which is 15 cubed. And again, make sure you know how to cube something on your calculator. Again, use that little up arrow or caret key, 15 cubed on the calculator. So punch that into your calculator. Notice that we want it in terms of pi. Most of these here with spheres we're going to do in terms of pi. So 2/3 times 15 cubed. I came up with 2,250 pi. And again, this is meters cubed. So again, it's half of a sphere, half of 4/3 pi r cubed. Again, don't remember for the volume that you are cubing that radius. And then the other half of this lesson is on surface area of a sphere. So our formula for the surface area of a sphere is 4 pi r squared. 4 pi r squared. So go ahead and pause it, take a minute, copy down your formula. So then down here in number 7, it says find the surface area of a sphere with a diameter 76 centimeters, give your answer in terms of pi. Well, if my diameter is 76 centimeters, that means my radius is half of that. So half of 76 is 38. And I know that the surface area of a sphere is 4 pi r squared. So 4 pi, ooh, maybe I'll just plug it in right away. 4 pi times 38 squared. So plug this into our calculator, again, in terms of pi, so you don't have to push the pi button. So when I plug that in, 4 times 38 squared, I got 5,776 pi. And again, this is centimeters squared. Notice with surface area, it's the flat surface to cover that sphere. So your units are only to the second power. Another example for, oh, there's the answer to that. Another example for a sphere, it says find the surface area of the sphere with a great circle that has an area of 49 pi. Again, the great circle is that circle that cuts or slices through the center of the circle. So we know if that area of that circle is 49 pi, remember the area of a circle is pi r squared, so obviously the radius of my circle is 7. So using a radius of 7, we want to find the surface area. So again, remember your formula for surface area of a sphere, 4 pi r squared. So we would have 4 times pi times 7 squared. 7 squared is 49. 49 times 4, use your calculator. We should get a surface area of 196 pi. And again, this is miles squared. Surface area is a flat surface, so my units are to the second power. Let me just double check. Yep. Okay, and then finally, I'm going to have you guys try this one problem, finding both the surface area and volume of this shape. Let me explain the shape to you. We have a cylinder, right, with a hemisphere scooped out of it. I always think of like when I go to a place to get ice cream and like a giant tub of ice cream, and then they're just making this one giant scoop out of it. So again, this is hollow on top, right? That's an opening or hollow on top, and this has been scooped out. So when you're trying to find the volume of the whole cylinder, and then subtract out the volume of that hemisphere. Again, hemisphere, half a sphere. When you're finding the surface area, you're going to want the lateral of the cylinder, one base of the cylinder, and then just half of a sphere, right? Because there's a surface that's been scooped out there, so the surface area of half a sphere. And then you add those pieces together to get your total surface area. So I'd like you to go ahead and pause the video and take a minute and see if you can come up with the volume and surface area of this composite figure. Pause it. Okay, so checking our answers for volume, the volume of the cylinder minus half the sphere. So the cylinder was 45 pi. The half a sphere is 18 pi. So 45 pi minus 18 pi is 27 pi. And again, we wanted the answers in terms of pi, right? In terms of pi. The little bit more challenging part here was surface area. So for my surface area, whoops, sorry. Surface area of my cylinder, I had the lateral. Wow, keeps jumping, sorry. My lateral was 30 pi. My one base was 9 pi. And then the half a sphere is 18 pi. So 30 pi plus 9 pi plus 18 pi gives me 57 pi. So 57 pi is the surface area of our composite figure. Again, surface area is feet squared, volume is feet cubed. So go ahead and look those over, check them over. Our homework for tonight, maybe I'll just write it down right here. Our homework for tonight, again, I did alter it, making it just a little bit shorter for you. It's page 49 in your packet, and we're doing numbers 13 through 26. 13 through 26. Again, practicing spheres, volume, and surface area. So remember those two formulas that I gave you today. Any questions, please reach out to me via email or Google Classroom. I'll talk to you guys later. Stay healthy.